Good afternoon, everyone. In this tutorial, we're going to start learning how to create visualizations using our data within R. So to get started, let's go ahead and grab a copy of mtcars so that we have some sample data to work with. And let's go ahead and open that up in view so that we can see what's going on. So the first type of visualization we want to learn is called a histogram. A histogram is the distribution of values along a single variable. So let's create one, and then I'll explain what it means, and hopefully that'll sort of make more sense of it. So to create a histogram, you use the function hist, stands for histogram, and there's one required argument that is what list of values do you want it to create a histogram of. In this case, I'm going to use the MPG field. So what this is showing me is the distribution of values within the MPG field. So if I look at the 15 to 20 bucket, this is telling me that miles per gallon values between 15 and 20 are the most common. That's why this bar is the highest. There are 12 of them. Values between 25 and 30 are the least common. There are only 2 of them. Let's go ahead and explore this bucket a little more. Between 10 and 15 miles per gallon, there are 6 values. So let's filter our data and let's take a look and see if that's, what's it's talking about. So I'm going to go ahead and filter df cars. I only want to see rows where MPG is less than 15. No filtering of columns. So when I look at that, I'm only seeing 5 values. What that tells me is there must be a car with exactly 15 miles per gallon. So I'm going to change this to 15.1. Okay, so if I filter my rows to see all the cars with miles per gallon less than 15.1, there are 6 of them. That's where this 6 came from. So any car that sits exactly on one of these borders, so exactly 15 miles per gallon, goes into the left bucket, I suppose. So that's what a histogram is showing us. It's showing us how many values in this field fit within each of these ranges. And it's useful so that we can, at a glance, we can just visually understand what values are common, what values are less common, and what's the sort of trend of values. If you want to see that in more detail, there is an additional argument you can use. This is an important one to know, called breaks. So here you can see we have our data split into 5 buckets. If I don't want that, I can set the number of breaks manually. So let's go ahead and create the same chart, but I'm going to set breaks equal to, let's do 10. So now I can see in a little bit more detail how the distribution of miles per gallon values goes. I can see that a lot of cars are sitting between 14 and 16, right? There are a lot of other arguments we can pass. If you want to see all of those, you can click on the name of the function and hit F1. That'll open up the help page for it. There are a whole lot of arguments here. First, it'll show you all the default values. Then if you scroll down, it'll show you each argument. We're not going to go into all of them. A lot of them are really specific, like aesthetic choices, like border, that sets the color of the border around the bars. That's something you might be interested in doing, but that is sort of a particular aesthetic choice. I'm not interested in that right now. One that I do want you to be aware of is this, main, X label, and Y label. This is how you set the titles for everything on the chart. So let's go ahead and run this again. I'm going to set main equal to MPG breakdown. Then I'll set the X-axis label to MPG. I'm fine with the Y-axis being labeled frequency. That makes enough sense to me. But now the titles are a little bit more sensible. It's not, the R syntax for the name of our field. This is a little bit more user-friendly, right? So that's how histograms work. Before we move on, one more important thing to be aware of. So when you're creating these and you're choosing how many buckets you want to break the data into, do be careful what number you set. So if we thought that 5 wasn't enough detail and 10 looks about appropriate, why not keep going up? So let's do 100. And what you'll see is this is actually a lot less helpful. This doesn't really show me the sort of trend of frequency of values. At this point, once we break it down into 100 different buckets, we're pretty much saying every car is its own little blip on the axis here, and that's a lot less useful, right? So choose a reasonable value when you're doing this. If you get too specific, this stops being helpful. The height of the bars is no longer telling me very much, right? Okay, so the second type of plots that we want to talk about are something called a scatter plot. A scatter plot shows us the relationship between two different variables. So let's go ahead and create one of these. To create a scatter plot, we use the command plot. Then there are two arguments that we have to give it. One for what variable to put along the x-axis and one for what variable to put along the y-axis. So here we'll do, let's say, mpg by horsepower. So what this is showing us is each one of these dots represents a particular car. So let's look at this one, the Mazda RX-4. It has 21 miles per gallon and 110 horsepower. So if I look at 21 miles per gallon and 110 horsepower, this dot is probably the Mazda RX-4. And when we put a dot on the plot for every single car, we can see the trend in the relationship between these two things. So cars with a really, really high miles per gallon tend to have a lower horsepower, and cars with a really, really high horsepower tend to be a little bit less fuel efficient, right? If we want to see the sort of mathematical relationship that's going on there, we can use a function called LM, that stands for linear model. The syntax for that is you put in the name of the two fields, so horsepower, then use the tilde key to get that little squiggly, and mpg, and then you specify where's the data set. So df cars. So this gives me the linear relationship between the horsepower and the miles per gallon. If you ran a regression between the two, this is what you would get. It's the normal y equals mx plus b syntax. The intercept is at 324, and for every miles per gallon you add, you tend to lose about 8.8 horsepower. If we want to put that line, so that we would call this the line of best fit, if we want to add that to our histogram, we can do that. Or I'm sorry, to our scatter plot, we can do that. All you have to do is use the command, what is it, AB line. And then I can put this whole line in here. So the whole linear model is what I put into AB line. If you wanted to, you could do something like this. You could, we'll call it fit, because it's the line of best fit. And you could put this whole function here. And then if I created the plot, and I wanted to add the line, I can do AB line, and then I can just add fit. So that shows the linear relationship between these two variables. Just like we saw with the histogram, there are a whole lot of additional arguments that we can pass to a scatter plot. I want the default plot. Here are the default values that are being used. If you want to manually set, there's all sorts of different things you can change. You can change the Y limits, that's how high and low the axis goes. You can add the main title, the subtitle. We can give it labels again. Let's do that again. So if I want to give it a title, I can say main equals miles per horsepower per mpg or something like that, or by mpg, because it's not per. I can give the x-axis was mpg, the y-axis was horsepower. So now we have nice, neat labels. This is a lot more user-friendly. If I want to add that line of best fit again, we can just do that. So that's how you create a scatter plot to show the relationship between two different variables. And you can see how you can add the line of best fit as well. If the dots hug very tightly to the line, we would say that's a very strong relationship. If there tends to be a really big gap between the line and the dots, we would say that's a looser relationship. In this case, this is a fairly strong relationship. We can measure that using r². We'll talk about that later. One other thing you can do, if you want to, rather than seeing a linear relationship, if you want to see a smoothed relationship, you can use a function called scatter.smooth, and then just pass it the two variables that you want to plot against each other. So you can do it that way, and you can see a smooth line of best fit.